We are going to solve two problems from the definite integral section. So for the first one, f of x is 2x squared minus 5 for all x's between 0 and 5 included, and n is 5, taking sample points to be right endpoints. According to the formula, delta x is equal to b minus a over n. And according to the information of this question, b is 5, a is 0, and n is 5 also. So delta x is 1. xi will be a plus the multiples of delta x. Again, according to the information that we have, a is 0 plus I times 1. So each x is related to the I. Starting 0, the next one is the previous one plus delta x, which is 1. So the next one will be 1. And again, adding delta x to the previous one makes 2, 3, 4, all the way to 5. Now, the integral from 0 to 5 of 2x squared minus 5 dx, according to Riemann, and considering points that are right endpoints, is going to be delta x times f of, since it is about right endpoints, we don't count the first one and we will count the others. So the next one will be 1, starting 1, and then f of 2, and then f of 3, f of 4, and f of 5 here. Delta x is 1. According to the question, using calculator, if you plug in 1 here, you would get 2 times 1 squared minus 5, which means 2 minus 5, which is negative 3. So in here, instead of f of 1, I would write negative 3. If you plug in 2, you get 2 times 2 squared minus 5, which means when you plug in 2, you get 4. And then multiplied by 2, you will get 8. Minus 5 will be 3. So next one is 3. So you would do the same for 3, 4, and 5, and the results are 13, 27, and 45. Altogether, when you add them up and then multiply by 1, you get 85 as the sum. Let's do the next one. It's about using the definition of integral to find this integral from 0 to 5. It's basically the same as the previous one, but in here we are going to use the definition. That would be more accurate. So according to the definition, we again need delta x, but the difference is for the previous one, we had 5 minus 0 over n, which was 5, but in here we don't have any specific n, so we would consider n as a general number. It will be 5 over n. And xi, as before, is the first one plus multiples of delta x. First one is 0, I is just I, and delta x is 5 over n. Altogether, we would have 5i times n over n. So according to the definition, 0 to 5, 2x squared minus 5 dx will be limit of sigma of f of x sub I delta x when I is from 1 to n and n approaching infinity. We know that limit and sigma are just here, 1 to n. When n approaching infinity, it will be 2 times 5i over n according to x sub I squared minus 5 times delta x, which is 5 over n. And if we simplify somehow here, we would get from 1 to n approaching infinity. And we're going to bring out 5 over n. So I would write it this way. 5 over n times the sigma I from 1 to n times, we know that 5 squared is 25 here, multiplied by 2 will be 50 over n squared times I squared minus 5. And again, we keep 5 over n outside. But according to the properties of sigma, we can bring out 50 over n squared because it is not related to I. So it will be I from 1 to n here, I squared inside sigma minus 5 and sigma nothing means 1. I equals 1 to n according to the properties of sigma. If you think you don't remember, you can review that. So limit of 5 over n approaching infinity is we can have 50 over n squared, and instead of the sigma of I squared, according to the formulas that we had, it will be equal to n times n plus 1 times 2n plus 1 all over n all over 6. And if you need to review this, you can check the worksheet about this one. Minus 5 times n according to the property. So limit of 5 times 50 is 250. And if you multiply n and n plus 1 and 2n plus 1, you get 2n cubed plus 2n squared plus n. And you would have for the denominator 6n cubed because we have n squared here and n here. Minus 25 because if you multiply 5 over n by 5n, 5 multiplies by 5 would be 25, and this one will cancel out. Okay, when n is approaching infinity, it will be limit of, if you multiply them, you would get 500 n cubed over 6n cubed plus 500 n squared over 6n cubed. Just you multiply the top and you would separate the fractions. Plus 250n over 6n cubed minus 25 when n is approaching to infinity. So for the first one, we know that n cubed and n cubed can be canceled out. And for the second one, we know that when we have n squared over n cubed, this will be canceled and we're left with 1 over n. And since n is approaching infinity, 1 over n will be approaching 0. Also here, if you cancel n and one of these, you're left with 1 over n squared. And since n is approaching to infinity, this one will be 0. So altogether, we would have 500 over 6 minus 25, which will be approximately 58.3, which is more accurate than the previous one.